Hello, algebra class, coming to you with some answers for 12.7. There was a question on the homework, so I'm going to go over. The questions were numbers, let's see, this is 12.7 homework help for numbers 10, 12, and 34. Bing, bing, bing. Okay. So number 10 and 12, they are in this chart here, and I know that you guys have access to all this information on RenWeb still. So you're able to get the answers, showing you the answers. Obviously it doesn't help you because you need some of the understanding. So numbers 10 and 12, I'll do them separately. But again, I've got my notes here for 12.7, and that's going to help us go through it. So for number 10, the function is negative 1/3 x squared. And it asks us things like the vertex, the, whether it's steep or its direction. And so let's just look at this and kind of go through. So first off, is this direction going up or down? That means obviously it's a parabola, right? It has the x squared, but are the arrows going to be pointing up, or are they going to be pointing down? Now from our notes, we know that any negative parabola will be opening downward. So our parabola is going to be something like this. So it's pointing down. Now the vertex, this is on the second page of the notes, and it talks about the vertex being at 0, c. So whatever our constant is that's being added is going to be the, right, because our vertex is a point, right? That's this point right here where everything starts turning around. And the vertex, of course, the point is x comma y. So our y value is whatever this constant is. In this case, it's 0. And in 12.7, all of our x values for the vertex was at 0. So I'll just put this at 0, 0. So it is facing down. It does have the vertex of 0, 0. Now, for minimum and maximum, I didn't really cover that. So things that I don't cover in the notes, I don't grade you for. However, it's fairly straightforward. Anything that's maximum. So this is our parabola, roughly, right? Because it's downward facing. That means that the vertex is the maximum point. No other point on this function is going to be higher than our vertex. Whereas if we have an upward facing parabola, right, a positive parabola, then our vertex, which is still going to be here where it changes direction, that's going to be the minimum of this. So the vertex is at 0, 0, and it is the maximum. Max, that's an A. Maximum. Okay. Now, when we're comparing it, right, the usual function is x squared. Here we are. I'm in my own room, and my hand is still getting in the way of the notes. So typically we have x squared. That's our normal. Parabola, like as far as the steepness. Now, again, looking at the notes, if the absolute value of a is between 0 and 1, the parabola is wide or flat. So we would say that this parabola is wider. what that means, let me show you here. So if we have just a regular x squared, we know that we're going to intersect right there at the vertex. If I draw out a simple t-chart, x, y, -1, 0, 1, I'm going to be at 1, 0, and 1 for my y values. So my, let's see, I also know that 1, 2, 3, 4. So our typical parabola is going to be like this. But this guy at -1/3, I'm going to do x, y, -3, 0, +3. You'll see why I chose those numbers, because I've got -1/3 times -3 squared. Well, -3 squared is 9, +9, but +9 divided by 3, rather +9 divided by -3 is going to give me -3. So my vertex is still here, but at -3 I'm here. So it's going to go something like that. And it's just wider than our typical parabola. Okay, so that's number 10. Number 12, let's see, where's my handy dandy little eraser go? Just do this. Number 12, our function is, let me get that out of the glare, sorry, that says 12. But our function is 1/5 x squared, so 1/5 x squared minus 7. Okay, well, it's positive, so we know that it's going to be facing up. Our vertex is, again, it's 0, c, while our c is -7, so 0, -7. And because our coefficient is between 0 and 1, rather the absolute value of our coefficient is between 0 and 1, so it's going to be flat. And it's going to look something, maybe I could do that in a different color. I did bring different colors somewhere. Maybe this will look, no, that green and light blue look almost the same. So let's call this x, y. Again, I'm going to do -5, 0, 5. So I've got 1/5 x squared. So -5 squared is 25 divided by 5. It's going to be 5, 0, and 5. So again, now this time, because it's minus 7, I forgot to do that. So that's going to give me, instead of 5, it's going to be a -2, -7, and again -2. So 1, 2, 3, 4, 5, 6, 7. And then at 1, 2, 3, 4, 5, I'm at -1, 2. 1, 2, 3, 4, 5. Right, so my parabola, it is upward facing, but it ends up look something like this. Okay, so again, it's wider than this guy. Okay, now number 34 asks for the point of symmetry. So symmetry for any function in the form of ax squared plus c. Now, there is one answer. Point of symmetry is where can I fold this parabola so that way, right, it'll match whichever is on the other side of the fold. And in this case, it's always this line. It's always the y-axis, right? If you notice, all these guys have their vertices on the y-axis. So for number 34, let me do it over here. So number 34, because all parabolas in the form of ax squared plus c have a vertex. You don't really need to answer all this, but this is the explanation. Have a vertex on the y-axis. And it asks the equation of the line. Well, if that's the on the y-axis, that's where x equals 0. So this is the answer for number 34. Hope this helps. And otherwise, love you guys. Talk to you later. Bye.